morning, everyone, and welcome to the Mathematical Finesse, the class of Mathematics of Change. Calculus 1. Now then. Pencils out, everyone, and calculators. Be careful with them, and do not forget your copy of calculus of a single variable, of course.
Professor Slughorn,
Ready, my girl?
we haven't got a book or a calculator or anything. We didn't realize we'd be able to take this college and school seasonal course this year.
Ah, yes. Professor Reliable did mention something about that. Not to worry, my girl. Not to worry at all. You can use one calculus from that bin, and we've got a small stock of old books here. That'll certainly do you until you can go to the collection box. Yep. Now then, I wrote a board problem and a symbol for you to examine. I also have a picture for you to look at. These concepts are just the tip of the iceberg of what you'll see after completing this college and high school class. You should at least heard of these, although by no means do I expect you to be able to do these problems right away. Can anyone tell me what this first problem is?
Oh, it's a limit problem. If you solve it correctly and say the answer with a flick of your wand, you can get anyone you want to tell the truth.
Wonderful. And what about this symbol? This one is more common. I haven't seen it in a mystery leaflet before.
I know what that is. It's an integral sign, used in integration. Solve one of those and flick your wand, and you can transform into any person you want for 1 hour.
Excellent. Now class, we won't be getting to those until the second semester, but it's good to at least recognize symbolism. Symbolism will become very important for classes as we progress. Extremely. Now this one, right here.
That man right there is the late, the great Sir Isaac Newton.
It is indeed. I suppose it seems rather foolish of me to ask, but I think you must know what he accomplished.
Yes, ma'am. He's the father of calculus, of course.
May I ask your name?
Hermione Granger, ma'am.
Granger. Can you possibly be related to the Hector Dadworth Granger, who founded the most extraordinary society of potioneers?
Probably not, ma'am. A muggle born, you see.
Ah, one of my best friends is a Muggleborn, and she's in the back of the class. Is that this person, Aries?
Yes, ma'am, that's her.
Well. 20 points for Gryffindor with Granger.
Did you really tell her I'm the best in her year? Oh, Harry.
Now it's time to start work. I will show you an example of a limit problem, and then I'll have you guys try another 2 examples on your own. You may use your books, and the first person to solve it gets this as a prize.
Oh, I heard that sweatshirt gives you good luck on test days.
Is it really?
Serious?
Ah, you're right there, Miss Granger. Now to do a limit problem. This x approaches 0 means that we will have to plug in 0 for each x. Of course, when we plug it in, it will come out as, 0 minus 0, which we cannot use because we can't divide by 0. But if we multiply by the complex quantity on both sides of the fraction bar, which would be square root of x plus 1, notice the different sign change, over square root of x plus 1 plus 1. Now remember, it's important to make sure you multiply on both sides of the fraction bar, because that will mean it's in the form of 1. That will make it x plus 1 minus 1. X minus 1 plus 1 over x times square root of x plus 1 under square root sign plus 1, all in parentheses, and the minus 1 and the plus 1 will cancel out, and so will the x on both sides. So that's form of 1, which will make it 1 over the square root of x plus 1 plus 1. And now if you plug this in, you will get 1/2, which is our answer. And now you may now do those two problems in red.
How are you getting that? You just take the derivative. No, it's a limit problem. Professor Slughorn said so.
I think I found the right answers.
See, take it. Harry, you must have gotten your gift for calculus from your dear mother Lillian.
Thank you, ma'am.
Why don't you go up to the board and show them how you did it?
Okay. I noticed that if you just take the limit as x approaches 0, and you plug in 0 cubed plus 2 0, you get 0, which you can't use. So I found that it's easier if you take the limit of the derivative, which would be 3x squared plus 2. So you plug in 0, so you get 0 plus 2, which equals 2. And then this one, you have to FOIL the problem first. So you take 3 to that, so it's 15x. Then you collect all your terms. Should be 8 cubed plus 2x squared plus 15x. Even now, if you plug in your 0, you would still get 0, which you can't use. So you take the derivative. So you would get, let's see, 4x squared plus 4x plus 15. So now, if you take the limit, it will equal 50. And that's how I found the limit. Not nice.
Not again.
I am impressed with this. Now, one more thing I would like to notice. There is a way to do this without foiling. May I have your marker? There's a thing called the product rule that if you take the the first, which is 3x minus 2x squared, times the derivative of the second, which would be 4x, 4, plus the second times the derivative of the first, to be 3 minus 4x, as she so well pointed out with the power rule. Now then, if you would collect and keep on going, you would find that you get the same exact answer as Mr. Potter. Very, very nicely done. Class dismissed. Tomorrow night.